This is exercise 7.236 that gives us information about a random sample of 30 managers' salaries, and we want to test a claim that has been made about whether we believe that the average salaries of all managers is actually more than the national mean of $85,000. So basically, we want to see if we have evidence to say that, which means we want, in our alternative hypothesis, to say that mu, the mean of the population, is greater than 85,000. So we can rule out any of these options that do not have a mu is greater than $85,000 in our alternative hypothesis, which obviously leaves us with only one option. The complement of being more than $85,000 is less than or equal to $85,000. Now, just a note, it would be acceptable in the null to say that mu is equal to $85,000, but the alternative must say that mu is greater than $85,000. So the second part of this question is asking us to calculate the standardized test statistic, and that is figure out how different our sample average is from this claimed population average in standard deviations. So the formula for our z-test statistic first has us calculate the difference between our sample average, x bar, and the claimed population average of mu, and divide it by the standard error of the sampling distribution, which is the sigma, population standard deviation, divided by root n. So we've done this many times before on our calculator, but I have provided some screenshots from mine. What I did was I went to Stat Edit, and I entered all of those values from the table into List 1. Then I went to Stat Calc and chose one variable statistics. And some calculators require that you give the list name, and so you'd type second 1 for L1. And then I hit enter, and here are my statistics. So clearly my sample average is $87,829.33. So in calculating my z-score, my x bar is $87,829.33. It says round all intermediate values to 3 places, so I'll say 0.333, minus the claimed mean of $85,000, divide by the standard error, which is our sigma given to us in the stem of the problem. It was $8,600, divided by the square root of our sample size, which would be divided by the square root of 30.
Put yours up.
And when we calculate that value, remembering, of course, that it's important that if we're going to put this in our calculator, we need parentheses around the numerator and denominator, we get a z-score of, a z-test statistic of 1.80. What that basically represents here, guys, is that our claimed population average was 85,000. That's at the center of our normal distribution. Our sample average is 1.8 standard deviations above that claimed average. And when we go and calculate our p-value in the next step using our table or our calculator, we're going to be finding the area in that tail above that z-score of 1.80. Above because of the fact that in our alternative hypothesis we used a greater than alternative, which makes it a right-tailed alternative.